There. All right. Here's the question. So the probability histogram is to the right, and it's about mothers. It's about a mother, 44 to 49 years old, who had a live birth in 2012. Okay, and there's the probabilities. Now, this is the same thing that we did last Thursday, except last Thursday it was more of a table. Had this and that, and then it had X and P of X, and it had 1, 2, 3, 4, and so on. And then over here you had your probability of 0.239. And then you had your probability of 0.249 and so on. So the only difference in this question and the one that we did Thursday is that this is in a histogram form versus a table form. So you can make a table or you can get your information from here. I'm going to make a table. All right. And of course, if I'm going to make a table, I'm going to pull it up as an Excel. If I can find the Excel. There it is. Because I think the question usually, what's the two most important numbers in probability and statistics? Mean and the what? Standard deviation. So you can bet your bottom dollar it's going to ask you for one of those two. I don't know what it's asking, but I'm going to go ahead and do it. So here's X, and that's going to be 1, 2, 3, 4, 5, 6, 7, 8. And then I got to make this go down. And I got to pull this, there we go. And this is P of X. That means the probability of that event happening. 0.239, 0.249, help me out, is that 169? 0.169, 0.113, okay. 0.169, 0.113, 0.105, 0.036, 0.041, and 0.048. Everybody with me? All right, now I got it in a table form. Remember when I told you a lot of the times there's two things you can do in this class. One, read the question and think about the question, because this question we did Thursday is the same question except it's in a different format. So you've got to realize that. The second thing is the formulas will tell you what to do. The formula will tell you, that's the directions. Well, we ain't got to the formula yet because they're asking for something else. So what I'll do is I'll get rid of this. I don't know what I just did, but anyway. Let's go to the question and see what it's asking. The question asks, what is the probability, blah, 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 had her fourth live birth? You know I can't stand here myself. Why are you doing that? You're distracting. You're distracting. Now I can't concentrate. Class is over. All right. 4 births is point what? 113. So you go to your handy dandy cursor and you type in 0.113. We're fantastic. Now,
That's not it.
what? Yeah, I'm not going to read all this because all this is crap. Okay, don't read that. Read this. Her fourth or. What does or mean? Add. Fifth. Fourth or fifth. That would be 0.113 plus 0.105, which is 0.218. I did that in my head, y'all. 218. Fantastic.
Like you're romantic.
I know. What is the probability that a randomly selected, don't need to read all that, 6 or more? 6 or more. What are you going to do with all three of those? And 0.125, somebody check me. Well done. And there's the question I knew it was going to ask. It's saying blah, 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 blah. How many live births would you expect? When you got a bunch of numbers and the word expect is in there, they're wanting what? The average. So figure the average. Well, what is the average of a binomial, of the probability distribution? Well, we did that Thursday. The mean is equal to the summation of what? Look back in your notes Thursday. We're going to start using our notes. Go back and look Thursday. What does it say? The summation of something times something. X. Golly, y'all got you mean you got that out of your notes? Wow. Did y'all hear that? He got that out of his notes. Reckon y'all should start taking notes and maybe looking at them at home?
I did.
Okay.
We just answered Chris and
Oh, okay. Is that what it was?
Yeah, I know.
All right. So you look at the formula and it tells you what to do. So what are we going to do? Multiply x times p of x. And then we're going to add them all up. So we go over to our handy dandy Excel spreadsheet. And remember, I had to say this in the video also. I'm not telling you to use Excel. I'm using Excel because I write like this, and I can't get all this on the board. So I do it over here so I can present it. People get confused. They think I want you to use Excel. I say you can, but you don't have to. You can use your TI-84 or 83. Okay. Now I got that out of the way. X times P of X. So I take my handy dandy equal sign and multiply by that and enter and copy that down. And what I do after I do that? Well, you go over here, X times P of X, I do what? Add it up. Sum it up. And there's my mean. So the mean is equal to that number right there. Well, let's talk about what the other number is. I'm going to move that over here, and I'm going to say the standard deviation, or the variance, sorry, is sigma squared, or S, or S squared, is equal to, what do we got to do now? What's the formula say from last Thursday? What does it say? The summation of
Minus. Wait, I have summation minus mean.
summation of what?
G7.
Huh?
Yeah.
The summation of x squared times what? Times p of x. It's not x squared times p of x?
It's
Huh?
minus. It's in
times p of x, and then minus the mean squared, right?
Yeah.
Well, y'all give me time to get it out. Oh, no, that's not right. Well, I ain't finished yet. X squared times p of x minus the mean what? Squared. And then, of course, you take the square root of that to get the, I'm just going to say square root of this squared. So take the square root of that, and that's going to give you your standard deviation. So look at the formula. The formula says what? I need what? I need x squared. I don't have x squared over here, so I got to get an x squared. So you write on your paper x squared column, and you square x. I'll do the first one for you. That's 1. Okay? That help y'all? And there they are. Now what I do, go back to your formula. What do I do with x squared? I multiply it by what? P of x. So x squared times p of x equals x squared times p of x. And then I sum that up. Go back to your sum that up, and then minus. So I'm going to sum that up. And now I'm going to take my variance, I'm going to put right here, is equal to this number minus parentheses, minus parentheses, this number, what? Squared. There's your variance. And the standard deviation is equal to what? That number raised to the what? 0.5 power. So, for 6.1, whatever chapter we're in, is this 6.1 or 7.1?
6.1.
I'm sorry, what? 6.1? All right. For 6.1, you have to know 3 formulas. And here they are. That's it. Now that's the second time we have went over those formulas. We went over them Thursday of last week, and we went over them today. So let's do another. Let's see if I can pull one up out of your homework. Really? Can't believe I hit that X. I did.
Did you get any rain yesterday?
What'd you say?
Did you get any rain yesterday?
Yeah, a little bit, but not much. We need about 3 or 4 days.
You got really smart today?
I hope. Look, it rained for 3 days. We got hay fields. We got hay in it dying.
Did you say you opened the homework up?
I thought I did. Well, I left it open I hadn't put an end date on it. At least I thought I did. I'll check it after class if I ever get back into it. Homework. I guess I didn't.
It's okay. We'll do it later.
No, I can't even get into it. Just about ready to quit.
Yes.
I went in and I asked y'all what chapter it was. I checked it and I put today's date. Do it again. 6/1, 6/2, 21, 7/2, 3, 8/1, 8/2. And I went up here and I put in today's date. Put 8:00 a.m. There. Let me try it again. Homework.
Is it usually automatic or you have to wait?
You do it right after I do it. Did I not do it? Did y'all just see me do
That's all
it?
you do.
Go check it again. Oh, I know what's wrong. Hadn't been assigned. Sorry. Assign, 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 assign. Now, wait a minute.
This one, this one.
Which one?
I don't know. Right there. Oh, it's a review quiz, sorry.
Thank you very much. Can I be in charge for a while?
I suppose.
All right. Now let's try it. There we go. This is 6.1.
Now you did a good job.
Something's changed. Looks different.
It's been updated
Oh,
and it sucks.
okay. That sucks. All right, there's your one right there. Let's do this one. I don't care about what they're asking you. Well, no, they're not. They're just asking you to test. Let's find one that they're asking you for something. That's the one we just did. Really? Okay, this book sucks. All right, just do this one because that's the one I'll give you on the test. Okay? Let me turn the light off so y'all can see it. And I'll blow it up and get everything disoriented so y'all can't see when I do the problem. Okay? Lawyer's office is calling. I tell you what, they don't listen to me. I tell them I have class at 2:30 and they call me at 1 o'clock.
Aren't they local people? Aren't they local people?
Yeah, it's all about them. Doesn't matter what you say, they don't listen to you. All right, do that one. If you can't do it, then just consider yourself what?
Loser.
A failure. Why can't they let you see all of the parts?
It sucks having to click and check
What?
the answer. It sucks having to keep clicking.
I don't
You
want
can
to.
just see it all.
I can't. I have to click the answer. I have to put. I don't want to do that. I want to project everything, but don't worry about it. Go ahead and make an announcement here, but I got to turn this off. Okay, I got to turn this back on now. We got to be professional now. All right. Y'all can't see it? Here you go. There you go. Let's just turn off the lights so everybody goes to sleep. There you go. Be nice if they had a little tab that you could put in the. They don't have your tab that you can put it in the. Let's shut up. Now see, what you can do is pull up your Excel spreadsheet and just type those numbers in. And then you just take your handy dandy spreadsheet. 0.238. .259. What is that? 165?
That's what I got.
We're gonna say 165. 0.114. 0.099. 0.033. 0.038. And 0.054. And see what y'all got.
Can you slide it over?
Can I what?
Slide it over?
Slide it over. I'm sorry. Let me just do this. There you go. Check your numbers. See what you come up with. Y'all watch the news today? The what? No, I was referring to the. Did anybody die? I was referring to the Benghazi report that came out today.
About Hillary?
Well, about the whole thing, not just Hillary, but you need to watch the news. I mean, honestly, I don't even want to talk about it. Everybody needs to watch the news on it.
We just watched 13 hours for the news.
Well, yeah, go watch that movie and then watch the report.
13 hours?
Yeah.
It's not scary. Don't watch.
I'm sorry, what?
It's not scary. Don't watch.
No, 13 hours is about Benghazi. What happened?
I'll watch it though.
Everybody should go watch it.
Is it like at the Red Box or?
Yeah, well, it's on direct now.
Yes. I'll watch it tonight.
Well, you need to.
I need to.
Everybody does. Unless you want to live under a rock. And if you want to live under a rock, then don't go see it. And don't watch the news. A lot of people want to do that. Will you please?
I was watching videos the other day.
All you hear is my loud mouth.
All I hear is you.
I'm glad you said that. I just didn't have the heart to say it.
I was doing my homework and my husband said, "That's your voice?" I was like, "Yes." You talking to people like that? She said something mean to me first.
I didn't say anything mean to you.
Whatever we were talking about, you did.
Oh, it's my fault.
You picked on me first, and then I picked on you.
It's my fault. It's Bush's fault. All right, so here's our question. Oh, is that it? All right, and it asks for, is this the problem? No, that's the old.
I'm stuck on the line.
That's the old problem.
Yeah, I got all those.
Here's the new problem.
Can you go back? Ooh.
Can I go back? What?
What's that last one that you had pulled up? Is that one the same one?
That was the one we did a while ago.
Yeah.
This is the one we're doing now.
Okay.
All right. What is the problem? Blah, blah, blah. Fourth live childbirth. So fourth live childbirth is 0.114. 0.114. And we got an excellent. And then fourth or five is going to be these two together. And y'all going to have to tell me what that is. 0.213. Huh? Uh-huh.
0.213.
Thank you. No, it's just that enunciation and volume goes a long way. What is the probability? Blah, blah, blah. 6 or more. That's going to be these three added up. Which you could easily just go down here and take this and do this. And
Don't you dare while I'm trying to do it.
0.125.
That's correct.
Thank you.
You're welcome.
I needed that affirmation. 0.125. And then the average is 3.1.
You added them all up.
I'm going to go back to the formula. What is the formula?
M equals
Summation
times px.
of x times t of x. And the first thing people are going to say is, well, what's x and p of x? Well, here it is. I'll even highlight it for you. There it is. And here is the column where I take x and I multiply it by p of x. Right there. Capiche? And that's how you do 6.1. Now, the only thing is, the homework, whoever designed this homework, which I don't agree with, we're going to go find one that actually does find the standard deviation. So, give me a second. And I'm going to go to this, and I'm going to go to chapter contents, 6.1. Yeah, that looks a little bit better. Instead of 5 homework questions. Okay, here's a test question right here. I've shown you one test question. That's the one we just did twice. And here's another test question. Somebody tell me what the missing probability is.
Oh, I haven't read one.
I like questions like that.
I still get people missing.
You add up the one, you add them all up.
No, add up 2.6. 2.6. What's the answer?
I was just telling you how to do it.
I'm just bugging you. I was trying to get somebody to subtract 2.6. How much? 0.29. Now that is a test question. Please don't what? Screw it up. You add them all up and subtract it from 1, because the probability of 1 is the total probability. Let's see what this one says. Okay, this one is a test question. Write this one down. This is a test question. It says, in the following probability, blah, 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 blah. Draw a probability histogram. Well, starts at 0.2, then it goes up a little bit. Then what does it do? Are y'all listening? Okay, let's start over. It starts at 0.22, then it goes up, then it goes down, then it goes up, and then it goes up. So where do we see normal, normal, down, up, up? B. Oh, did you say D? I thought C. Enunciation. D is in delta.
D is in delta.
Yeah, there you go.
Ghost Rider.
Yeah, whatever. They go foxtrot. See, that's an easy question.
Egbert.
Egbert. It's echo.
Echo, that's it.
Oh my, look what they're asking for. What are they asking for, people?
Oh my God.
Those that are listening to the question. It's asking for the mean. That's because that homework sucks. I'm pulling out questions that you'll see on the test.
The U to the little X means mean.
Mu.
Mu.
Mu. All right, find the mean of those probabilities. Yeah, this is a test question, especially if it asks standard deviation. I found these in the study plan because whoever was the lead instructor that did this, they only picked the crappy homework questions. They didn't pick the ones that actually you learned something. This is Shark Week. Y'all know this is Shark Week?
Every year my friend goes on vacation for 2 weeks. It's Shark Week.
I love Shark Week. I watch all the shows that are about sharks. And my son fell asleep last night watching sharks. Woke up in the morning about 1 o'clock and there's still a shark going around the TV. Hmm? What was that?
That was called joy.
It sounded like somebody went, baby!
I got a question right.
Alright, so I take my handy dandy click to copy table icon and open in Excel. There it is. I can do everything from here. Enable editing first and make it a little bit bigger so y'all can see it. There's always going to be somebody that sits 500 feet away from the board. Now you sit there and you stare at it and then you say to yourself, how do I get the mean? Well, you look at the formula. X times P of X. So I've got to start a problem here. Start a column. X times P of X. I'll do the first one for you. 0 times 0.228. Now you might need a calculator for that. What's this 6 sit for? And then what do you do with that? Sum it up. And that's your mean. So now you got to find the variance, because you can't find the standard deviation if you don't have the what? Variance. So the variance is equal to the summation of x squared times p of x. I'm going to put that in brackets. Minus the mean squared. So if you haven't done it, do it. Take your notebook, paper, and draw another column. And that column is going to be x squared. And then draw another column, and that's going to be x squared times p of x. X squared, so I'll do the first one for you. That'll be 0 squared. Punch that in your calculator. I'm talking to that person, don't know what the 6 cents for. Some of y'all are wondering, what does that mean? Y'all ever been somewhere and the cashier is an airhead? And you just want to mess with somebody? So you give them $20 and your bill is like $11.56, and you give them the $20 bill and they ring it up and you give them 6 cents and watch their head explode. It's pitiful, but it's fun to watch. Oh, now the real estate agent's calling. So now we've got the real estate agent and the lawyer's office calling. Yeah, I tell every single one of them. 2:30 is when I get out of class. Do they listen? No. So this is going to be x squared. What'd you say?
That would be common sense.
Yeah.
So common.
Times p of x. Not everybody's real estate agent can be Donald Trump. I just don't understand. That's a joke. Better than alternative. I can't even think now that I mentioned the alternative. X squared times p of x equals p of x is right there. Oh, you get the same answer. I wonder why. That's a miracle. And we sum that up. I get 5.493. Y'all check that. And that's this guy right here in the brackets. That's that guy. So the variance, I'll just go down here. Variance is equal to this guy minus parentheses this guy squared. And then what is the standard deviation? That, what? To the 0.5 power. Square root. And there you go. Now, if you do it in your TI-83, you punch it in. Go stat, edit, dang old L1 and L2, 0, 1, 2, 3, 4. Then you go over to L2, 0.228, 0.245, 0.165, 0.172, and 0.19. And you go over to stat, dang old calculate, dang old first variable stat, second L1, comma, L2, enter, dang old, there it is. There's your variance, and your standard deviation is 1.44, and your dang old variance, 2 point, they don't have the variance on there.
Wait, how did you do variance? I mean, you're closing that formula. Oh, okay.
Calculate. Variance stats, the first one?
Yes, first variable stat.
Variance.
And there's 1.43, there it is, 1.438. Say again?
It's all good.
What's it do? Did you type in shift L1, comma, shift L2? Do first variable statistic, and then type in shift 1, comma, shift 2, and then enter.
For the variance, the mean, I know the mean, but like, I didn't know which numbers you put in the square. Yeah, that.
Well, you take x squared and you make that column. And then you do x squared times what? And there's p of x.
Where's shift? You said shift.
Second, right there.
Second.
But the 2.067, is that the overall variance?
That's the variance of all these right here, yes.
What did you do? Just add all those up?
Oh, wow, I did.
And
That's what this says right here. Add those up and subtract what? Y'all are not looking at the formula. You take that x squared times p of x and you add all those up. And then what do you do? Minus, that's how you say minus. Minus the what squared? Mu squared. What is mu? Mean. Take all this minus the average squared. Or the mean squared, whatever you want to call it. And you type it into your answer. I don't know what they want for the answer. Let's see. Round to one decimal place. So that's 1.9. What do they ask for next? Oh, we talked about that. The observed value will be less than the mean of the radius. It's going to be, let's see, the mean of the observation will approach the mean of the random variable. That should be your answer. I ain't worried about that. I want you to be able to find the mean and the standard deviation of, and I'll highlight it. A mean, I want you to highlight that. And I want you to be able to find the standard deviation. If you can do those two things for 6.1, then you can pretty much handle yourself on my test, because I'm not going to ask anything else. And I've given you 3 or 4 problems to do. That's all going to be on your test. And this is one of them. Now, if you want to find this problem, it's not in your homework, because whoever made up the homework, they didn't pick it. It's 6.1, number 18 on the study plan. How do you get to the study plan? Well, you hit 6.1, chapter content, 6.1, study plan, and what I tell you the number it was? I'm sorry, what?
19.
Number 18?
I thought it said 19.
Let me check. Hold on. Number 18, yeah. There it is right there. Yep. Because I can't go back and change the homework. I'd have to delete everybody's homework and I'd have to go in and edit it. I'm not doing that. Because then y'all start whining about you've already done the homework and I ain't gonna do that. Let's see what 25 looks like. Yep, we done one like 25. We did that one. How did it jump from one? There's 25. Let's see what 118. I don't know what these things are. Yep, there's another good 137. I won't do one that long because that's too long. I won't do one like that. I won't do one like that. I've already told you the ones I would do on the test. That one. Okay? So you got 4 or 5 questions there, and I gave y'all one to do that you shouldn't, but everybody should get right. Where is it? I'm trying to find it. That one. Now nobody should get that one wrong. If you do, you don't what? You don't tell anybody.
You know, yours says 20 and I only have 11.
I told you this is the study plan. This isn't the homework. But that question is on your homework, I think. If it's not, it's going to be on your test. Okay. Now that's 6.1. 6.2. 6.2 is a little bit easier on y'all. Let's go ahead and turn to the calculator. For those of you that have a calculator, TI-83 to be precise, I want you to hit second bars, meaning variables, bars, second bars, and go down to number 0, binomial PDF. Now, with binomial PDF, you will need to type in 3 variables. So binomial I think it's PDF. You need to type in N, comma, P, comma, X. Now, what have I told y'all about N? N is usually always going to be your what? Biggest what? Biggest number, Hubert. Yep, that's right, class. So if I say you're going to flip a coin 20 times and it is presently being given a probability that it'll hit tails 0.49 and you're going to flip it 5 more times, then N would be 20. Biggest number is usually going to be N. P is going to be your percentage or your decimal. Now, every once in a while, a teacher or a book or a test question will say 25 out of 100. Well, they give you 25 over 100. What is that? 0.25 or 25%. So you have to type it in as 0.25. And X is going to be the desired or what you are flipping or whatever. Now, I like to tell students that this is kind of like a problem. I've got a coin, and that coin is been tested at 50 times. It's been flipped 50 times, and it has a probability of landing on tails 0.6 out of 10. 6 out of 10 of 0.6. All right? What is the probability that I will get tails if I flip that coin 10 more times? All right, so the first one is 50, the P is 0.6, and the N is 10. And you'll get the probability of that coin hitting whatever I said, heads or tails, if I flip it 10 more times, based on what you've already done. Now that's a nice example.
The 50 was N, the P was 0.6. And
I'm gonna write it down. I'm gonna put it on here. Hold on just a second.
Okay.
This is just an example that I use. I just made it up one day. A coin has been tested at 50 flips with having a probability of heads at 60% or 0.6. What is the probability of heads if that coin is the coin 10 more times? So N is equal to 50. P is equal to 0.6. And X is equal to what? 10. And you would put that in your calculator. I'm getting there, people. Just bear with me. 50. I have to switch everything when there we go. 50, comma, 0.6, and, oops, comma, and 10. Thank you. Okay? So that is what you come out with. Do not type them in the wrong way. If you type them in the wrong way and put the percentage first, then you're going to get an error or an error, depending on where you're from. Okay? Error, yeah. That's the way some people present it. Like people that are transplanted in Williamston, they say Williamston. Belton. I'm from Belton, South Carolina. Where is Belton? Yeah, they say Clemson. They don't say Clemson.
It's no P.
I know, because we're a bunch of ignorant rednecks. We call it Clemson. But people that are not ignorant rednecks, they say Clemson. Clemson. They put the Z in there. But it's okay for them to put a Z in, but we can't put a P in. It all depends on where you're from. Okay. So, 6.2, that's what we're going to be talking about as soon as I can get there. And there's another easy thing we do with, and that's what they're talking about, the binomial probability distribution. Now, if you want to see the fun part,
Sure.
here's the fun part. Let me find it. There we go. There's the formula you use by hand. I'll blow it up for you so you can enjoy it. So knock yourself out. Go ahead and write it down. There's the formula you use if you don't have a calculator. And if you don't have a calculator, write it down and have fun, because I'm not going to go over it, because it's a pain. So, actually, it's not a pain. It's just plugging in what? Now, there's P. That would be 0.6. And that last equation, I want everybody to take that last example, and I want you to plug in the numbers in this formula under that equation, under that example, so you'll know where everything fits. You got to do a combination. N, combination of X. So that's going to be 50, combination of 10. Then you got to multiply that number times 0.6 raised to the 10th power. Then you got to do 1 minus 0.6, which is 0.4, to the 50 minus 10 power, which is 40. And that's how you would do it if you don't have a calculator. Which you need a calculator to do that. Because not many regular calculators have the combination feature on it. And if you don't have the combination feature on your calculator, then you have to go and put combine in to your Excel spreadsheet. The long story short, you need a calculator, a TI-83 or better. Okay? So let's see where they're. Here's a question. Now I'm just going to do A right now. According to blah, 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 25%. Ding! What is that?
P.
P. Wireless households, blah, 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 20.
N.
N. 5.
X.
That's all there is to it. So somebody type in 20, or do your binomial PDF, and then do 20, comma, 0.25, comma, 5. And that's your answer. Should be like 0.20 something. Huh?
0.202.
That's it. 0.202. That's good. Thank you. Now, what does fewer than 3 mean? I'm not talking about in here. I'm talking about in math. Remember your pre-algebra and you were doing on the number line? What does fewer than 3 mean? Does fewer than 3 mean 3210? Or does it mean 210?
That would be 210.
210. So you add up NPX with 0 being X, then 1, then 2, and what do you do with those 3 numbers? Add them up. Now you need to get used to this right here. You're going to see some questions like this. And look at here. Table 9. You need to go back over that from your pre-algebra days. Fewer than 3. That's going to be the probability of 0, probability of 1, and the probability of 2 added together. With what? 20, 0.25, 0, plus 20, 0.25, 1, plus 20, 0.25, and 2. So let's do that. Do B. And you need to write it in your notes how you're going to do it. Because fewer than 3 means 0, 1, and 2. Now I'm going to do it with my calculator. Well, I sure don't want to do it with that formula. So, second bars, 0. What's the first one going to be? 20, comma, 0.25, comma, and what? 0. Now, watch what I do here. And I'm going to put that stow, alpha, A. Because that's my first number. And now I'm going to do the second thing. I just stow, alpha, and then I put math. See that little green A right there?
Yeah.
Okay, now, second entry, second entry. Now I'm going to type in what? 1. Enter. Stow, alpha, what? B. Enter. Second entry, second entry, and 2. Enter. Alpha, stow, where you get the bread. Second, alpha, C, enter. And now what we're going to do, clear alpha A plus alpha B plus alpha C. And that's how you use calculator. Not to take square root of 25 and to add 6 plus 7. Okay? 0.091 is your answer. Yep. I think I am.
Or you saw it live?
Nope. It's going. Okay, now you do at least 3. Now be careful here because you can use your brain and find at least 3 without doing too much math. At least 3 means 3 or more. At least 3 is another way of saying 3 or more. So you might want to, right there, top row right there, at least. Think of it as a number line. What's your lowest number for at least 3? What's your lowest number? 3. So that means everything above it. 3 and above.
That's what I was saying, we've already done all the other ones, all we have to do is 3.
Well, what is, if you think of the number line, watch this. I'll show you a trick learned in the war. Let me just draw a number line right here. And this is 0, 1, 2, 3, 4, 5, and so on. Dot, dot, dot. Okay, what did we just find in B? We found 0, what? 1, and what? 2. What is C? 3 or what? 3 or what? More, right? So do you have to do a bunch of complicated math with at least 3 or 4? I mean, at least 3? What's the C word I'm looking for? C-O-M? Say again? I heard complement. How can I do this problem and not do a lot of complicated math? 1 minus what? B. 1 minus your answer from B. Because isn't that the answer? So what's 1 minus whatever we got for that last one? Where's my handy dandy calculator? Hold on, let me get there. Oh, look at here, y'all. We don't have to do anything. All we have to do is 1 minus second answer. Look there. All you had to do was simple math. Now, the reason they give you this problem is to show you that 3 or more is the complement of what? Fewer than 3. And that's what they're trying to get you to see. That's a good question. All right, now look at this one. D. The number of households that are wireless, blah, 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 is between 5 and what? So what numbers are between? Now, does that include 5 and 7? What does it say right there? Inclusive. So does it include 5 and 7? Yes. So what's between 5 and 7? 5, 6, 7. So you're going to do the probability of 5 plus the probability of 6 plus the probability of 7. And I'm not going to type all that in, but I will show you the answer. Get this thing out of the way. Very aggravating trying to do all this in one screen. And I can't move it. It's a conspiracy. There it is, 5, 6, or 7. And they're doing each one of those and adding them together. There's your complement right there. There you go, complement rule, COMP. Now, there's one more thing in this section, and you're going to like it even better, because it's not even that hard. I got to find it first. Real hard. There we go. Now write that down on page 317. Now you might need to get a tutor to help you with this, because this is real tough stuff.
Are you being facetious?
Yeah, I'm being facetious. A binomial experiment with n independent trials. The mean is equal to n times what? P. What I tell you P was always going to be? A percentage or a decimal. Or it may give you, they may give you 25 out of 36. Whatever that comes out to be. And n is always going to be your biggest number. Well, in these questions, they're going to give you n, and they're going to give you p, and they're going to say, what's the mean? Now look at that example. According to blah, 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 the same question we were doing, 25% of all households. What's the probability of 300? What is the mean of 300 households? The mean is 75. You take 300 and you multiply it by 0.25. Well, what is the standard deviation? The standard deviation is going to be the square root of NPQ. Well, what is Q? Q is the complement of P. Y'all remember me telling you about the 65-cent lunch and I got 35 cents back? And I know that math real good because when I was in junior high, I always took $1 to school. Y'all remember me telling you that? Well, what's the complement of 0.25? 75. So Q is equal to 0.75. Okay, and that's how you do 1 minus P is equal to Q. Now you can say N times P times 1 minus P, or you can say N times P times Q. I like to say NPQ because I don't have to say all that other stuff. Okay? So, to get the mean, you multiply 300 by 0.25, which is 75. Then you take 75 and you multiply that by 0.75, which is 1 minus 0.2, be quiet. 1 minus 0.25, which is, and you got to take the square root of that, and that's 7.5. So with something as simple as this, you can find the mean and the standard deviation. The mean and the standard deviation drives everything in probability and statistics. Drives everything. If you don't have the mean and the standard deviation, there's not much you can do with statistics or probability. All right, so we'll do one more. All right, there you go. Construct. Oh no, that ain't what I want. I want to know the mean and the standard deviation. Why they got to mess it up? Here we go. According to, well, that's the same one we just did. Okay, we just did that. Let me see if I can find one in 6.2. Hold on. 6.2. That's not it. There we go. Study plan. Here's MPX. That's what your problem will look like with MPX. That one says X is less than or equal to 4. So what do you got to do? 0, 1, 2, 3, and what? And then you do what with those numbers? Add them up. Let me find an easy one that I'd give you on a test. Okay, well that's pretty much. Hang on a minute. There we go. I think this is one. According to the almanac, 80% of Marlboro Club started smoking before 18 years old. Blah, 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 blah. Compute the mean and the standard deviation. Okay? Do that. What is the rest of it? I don't care about the rest of it. I want you to find the mean and standard deviation of 80% of 18-year-olds smoked before. Okay, you got to have 200 trials. I'm sorry, you got to have that. Because you got to find the number. 80% of what? 200. And that's your mean. And then your standard deviation, what's the complement of 80%? 20%. And then you multiply that by 20% and take the square root of it. That's not hard. So let's do that. Take 0.8 and multiply it by 200. 0.8 times 200. And that's 160. Now, to find the standard deviation, you take that 160 and do what with it? Multiply it by 0.2 and then raise that to the what? 0.5 power. So your standard deviation is 5.7. Now they ask, what could they asked you a B question in C? I don't know what it asked, but anyway, what have I always told y'all to do with the mean and the standard deviation? Draw a picture. Remember me telling y'all that? That's what you're going to end up doing here. Well, what goes in the middle? That's not rhetorical. I'm asking y'all. Mean. Thank you. Even though I heard moon. So what's our mean? 160. And our standard deviation is what? 6. So that'd be 166. And 170 what? 172. And 160 minus 6 is 154. And 154 minus 6 is what? 148. Y'all check my math. And yes, I didn't use the 5.6. I didn't use that. I just used 6 because I didn't feel like doing all that in my head. Now, what is it asking you? Interpret the mean. Well, I just did. Now, would it be unusual to observe 180 smokers? Well, let's take B and let's put it on 180. Yep, right there. Is that unusual? Yes, because it's outside 2 standard deviations. Now our mean here is what? 180 or 160? What did it come out to be? 160? Well done, Hubert. The standard deviation is 5.7, isn't it? Look there. It's a miracle. Okay, I don't know. What is the correct interpretation of the mean? It is expected that the random sample adult 160 will have started smoking after turning 18. It is expected 160 will have started smoking before. Well, it says right here, before, right? Well, that's what it's saying. It should be before, right? And then the last one, yes, it is unusual. Why? Because 180 is above what? 2 standard deviations. And whichever one that is, I can't see. Hold on. It's not the first 3, so we can knock the first 3 out. Yes, because 180 is between mu minus 2 standard deviations and mu plus 2 standard deviations, or is it greater than 2 standard deviations? It's D as in delta. E as in echo. Right? Okay, thank you. As in Edinburgh. Would you say Eggborough? Egbert. Okay. And that's how you do it. Now you do this one. It says for 500 randomly selected adults, compute the mean and standard deviation of the number of adults who believe that overall state. Wait a minute, don't get, oh, up here. There's P right there. I didn't see P. P is equal to what?
68%.
68% or 0.68. Now you do the rest. Draw a picture and tell me if something is unusual when we get to it. Mean is equal to N is 500 times 0.68. Well, what is 10% of 50? I mean 500? 50. Okay. So 50 times 6 is 300, right? And then you could say 340? Is that what it comes out to be?
Yeah,
340. Yeah, you should be able to kind of do that in your head. So that's our mean. And then our standard deviation is equal to 340. And I'll do this, I'll write it out and then see if I can do it in my head. I don't know if I can or not. 0.68 is 0.3 what? 32? All right, what's 10% of 340? 34, Hubert. And that's going to be what? 102? 30% would be 102.
yeah.
Hold on, don't talk. 108.4.
It's,
Square root of 108.4.
It's 108.8.
Oh, I'm sorry. 108.8. Now, do we need a calculator for that? Probably not, because we know that 100 is square root of 10, right? 100 is 10 squared. And 11 is 121. Well, between 100, that's 20, 110 is equal to 10.5. So I would say, if I was taking a guesstimated shot, I would say 10.3. What would it come out to be?
10.4.
Okay. 10.4. So what do we do with that information? We take it and draw a picture. And our mean is 340. And our standard deviation is 10. Well, it's 10.4, Hubert. Yeah, but I'm doing it just to get some kind of picture of what is unusual or not. Okay, so that'd be 350 and 360. And 340 minus 10 is 330. And 320. So what numbers are going to stick out to me as being normal? 320 to what? Okay, so let's go back down here and see what the thing's going to ask us. It's going to ask us the mean of x is 340. Standard deviation is 10.4. It's a conspiracy. Interpret the mean. Well, I can't remember what we said there, but okay, we know that the mean is 340, so it can't be 500. It should be this. I don't know what they're saying because I can't see half of it. Somebody help me out. I don't want to erase this. That's not right. I didn't think it was. I was going to see this one. Let's see. Let me read. Suppose that a recent poll found that 68% of adults believe that the overall state of morals is poor. Okay? 68%. So that means 340 out of 500 say that what? 340 say that the morals are what? Poor. That's what I'm trying to read. I'm trying to read for the mean is the minimum number of them that would be expected. That could be true. Is the number that would be expected to believe the overall state. There we go. The overall state of moral value. I would say B, because that's no variation. Let me see what this says. Whether the mean is the range. I believe it's this. I believe it's B. Okay. Would it be unusual? Well, remember, what's our numbers? 320 to 360. What's that number? Is that normal? Yes. And you feel good about yourself.
Oh, we do not.
What? What did it do?
Focusing on the questions which we said everything.
You got to be kidding me.
We said everything there.
But we're not going to do that because
Okay.
we're good.
Well, somebody tell me what I did wrong. 350, or did I need to add the 10.4?
Maybe it only goes to.
Probably you used
That's
10.4 because in the title.
Okay, 10.4 and 10.4, you need to add that and see what you get. What do you get right here? You're still going to get 360.8, aren't you?
Yeah.
Right.
Well, then I don't understand why they didn't, unless I read it wrong. It said, would it be unusual? Would it be unusual? You would say no. I think I said normal and I said yes. I think that's what I did. I read the question wrong. But it's out here, it's right here. And is that normal? 357, is that normal? Yes, it's normal. Or it's not unusual. Sometimes those will get you mixed up. Okay? All right, I'm going to shut her down. I don't know what time it is. Time to go. Okay. They don't make me feel so good. Time to go.
You gotta go and part your.
Well, before I forget, I don't want to, hold on just a second before y'all leave. I'm going to write something down for y'all. Because I want y'all to get this right. Where is it? I'm sorry. I'm having a brain bubble. I'm going to write this down. Chapter 6. Well, that's not right. Chapter 6, which means 6.1 and 6.2. What's one formula that we need to know? One thing that we need to know is that when you're checking for probability distributions, the probabilities have to be between what? Has to be between 0 and what? 0 and 1. And all the probabilities have to equal what?
1.
Add them up, they have to equal 1. And the summation of the probabilities have to equal 1. So that's number one thing that you need to know for chapter 6 material. The second thing you need to know is that the mean of the probability distribution is equal to the summation of P times, the summation of X times what? X times P of X. And the variance is equal to the summation of X squared times P of X minus the mean squared. And we did that today. 3, you need to know that the NPX function is binomial PDF. And how do you get that? Second, vars, 0. And how do you type it in? N, P, and X, and I talked about what those were. And then the fourth thing you need to know is if given a population in a percentage, how can you find the mean and the standard deviation? Well, that's the mean is equal to N times P. You're only given a population, and you're given a percentile, you're given a decimal, or you're given a fraction, like 25 over 100. One of those three you're going to be given for P. And also remember that Q is equal to what? 1 minus P if you have to use the, well, I'm going to say NPQ. And the standard deviation is equal to the square root of NPQ, which Q is equal to 1 minus P. Now, those are the 4 things you need to know for chapter 6. And I have covered questions today that will be on your test from chapter 6. So that's what y'all need to be doing for homework before Thursday. And send your questions in. I get more questions from the online class than I do from y'all. I guess y'all just learn better than the online class. Is that what it is?
You have your encouraging words.
What'd you say?